Hello students, this is a revision video of the probability series and I am Gurmeet Singh, and also welcome to CREATA classes. In this video we will do the revision of the complete probability series. If you want to do the complete series on probability, the link to all videos is given in the description. Check it out. In this revision series, we will not only take down the basic concept, but we will also do some of the questions, which are important questions, but we will go very fast because this is only the revision. If you want to do the basic concept and the theory, go back to our probability series and just do the complete series. That will be really helpful. So let's start our revision lecture. Here it is. Probability is all about the visualization. So the two rules that you must follow. The rule number one, do not directly jump to the formula. It is always tempting to see the question and directly apply the formula. But we will not do that. We will follow the rule number one, that is, do not directly jump to the formula. Rule number two, we will visualize and observe the question. Probability is all about your visualization. How easily you can visualize the question, the more you will get your answer as correct. So we will follow both the rule. We will not directly jump to the formula and we will visualize and observe the question. So this is the formula of probability. This we will use. Here PE is the probability of the event. P is denoting the probability and E is denoting the event. Event can be getting the head in tossing the coin, or event can be getting the tail in tossing the coin, or getting number 2 in rolling the die. So these all are the events. On right hand side we have numerator and denominator. We will always start with the denominator. The denominator is the number of all possible outcome of the experiment. Here note that experiment is used and the word all is used. It means that the total output of the experiment will come in the denominator. Experiment means like tossing the coin, rolling the die, picking a ball from the bag. All these are experiment. All the output that we can get from the experiment will come in the denominator. That is all possible outcome of experiment. Got it? In the numerator, we will have the favorable conditions or the favorable outcomes. The number of outcome favorable to E. E denotes the event. For example, if we are calculating the probability of getting the number 2 in rolling the die, here the event is getting the number 2 in rolling the die. So all the favorable outcome of getting 2 in rolling the die will come in the numerator. Got it? This is the formula, the basic formula of probability, which will be used all over the questions. Let's take the famous case of coin. The experiment is tossing of the coin. When we toss the coin, that is an experiment and we are getting two events. Event of getting the head and event of getting the tail. We will only get two events, no other event is possible. Okay, either we will get head or we will get the tail. If we have to calculate the probability of getting the head, then head will come in the term of the event E. That is, we got P head. And if we use the formula of probability in the denominator, the total outcome of the experiment will come. That is 2, head and tail. So 2 event will come in the denominator. And the favorable case out of this 2 event of getting the head is only 1. That is head. So 1 in the numerator and 2 in the denominator. So we got the probability of getting the head as 1 by 2. Similarly, the probability of getting the tail we can calculate in the similar fashion. Denominator will remain the same. Only we will get tail in the numerator. That is 1 by 2. Note that this is a revision or the summary kind of video. So we will go slightly fast. If you want to do all this formula and all the cases in very detail, go to the probability series. You will get all the videos in the description. Moving further, we have got the probability of head and tail. Similarly, if we take the experiment of rolling the die. In rolling the die, we will get total 6 output. That is, we can get either 1, 2, 3, 4, 5 or 6. We cannot get 7, we cannot get 8 or we cannot get 0. We will get only 6 output when we roll the die. Let's calculate the probability of each event. The probability of getting the number 1 will be, let's start with the denominator. In the denominator, the total outcome of the experiment are total 6. That is, whenever we roll the die, we will get total 6 output or the 6 event. All the 6 event will come in the denominator. And what will come in the numerator? The favorable outcome. For getting the event 1, that is getting the probability of event 1, the favorable condition is only 1, that is the number 1 itself. So number 1 will come in the numerator, which is only 1. So 1 by 6 is the probability of getting the number 1 probability. Similarly, probability of getting the number 2, it will be 1 by 6. Because the denominator will remain the same, only numerator will change, that is number 2 will come in the numerator, that is again 1. Similarly, we can calculate the probability of getting number 3, number 4, number 5 and number 6 as 1 by 6. So we have calculated the probability of all the 6 events of rolling the dice. For example, we have to calculate the probability of getting a number greater than 4. How we will solve that? The number greater than 4 are 5 and 6. So if we use the formula of probability in the denominator, we will again get all the 6 events, because that is only possible all the 6 events when we roll the die. In the numerator, we will get number 5 and 6. That are only 2 numbers. So we get 2 in the numerator and 6 in the denominator. We got our answer as 1 by 3. Got it? Similarly, we can take different event like number less than 3 or number greater than 4, less than 5, different combination like even event, odd event. All these different event we can formulate and calculate the probability. If you're having still doubt, ask the question in the comment section. I will just reply. Okay. Have you observed the range of the probability is between 0 and 1 only? The probability cannot exceed 1 and probability cannot be lower than 0. That is, it cannot be in negative. It will be between 0 and 1. 0 means impossible event. 1 means full surety event. We can rewrite 1 in terms of percentage as 100% and 0 as 0%. So we can say the range of probability is from 0 to 100%. This is very important and generally asked in the exams. You should know this. We have got 2 observations in the probability. Let's check out the first observation. If we take the experiment of tossing the coin, we are having 2 events and probability of both the event, that is head and tail, is 1 by 2 each. If we add the probability of both the event or all the event, that is 1 by 2 plus 1 by 2, we will get 1. The addition as 1. Similarly, when we have done the experiment of rolling the die, we are getting total 6 event and probability of all the 6 event is 1 by 6. So if we add the probability of all the 6 event, that is 1 by 6 plus 1 by 6 up to the last 6 event, we got the addition as 1. So we got the observation, that is the sum of the probabilities of all the elementary events of an experiment is 1. This is very important. If we add all the probabilities of that experiment, it will add up to 1. Got it? The second observation that we have got is PE bar, which is also known as probability of not happening of that event, or P not E. For example, if we have to calculate the probability of no tail event, then we can write it as P tail in the bracket and bar. Bar is denoting not event, that is not tail event. The observation is that the probability of E, that is probability of happening of the event, plus PE bar, that is probability of not happening of the event, is equal to 1. PE plus P not E is equal to 1. We will take again our example of coin. The probability of head plus probability of not head is equal to 1. Let's see how we get this. Here, can we say probability of not head is equal to probability of getting the tail? Yes, we can say so. When we toss the coin, we are getting only 2 output. What is the possibility of not getting the head? That is getting the tail. When we get the tail, we can say it is not head. We are having only two output, so we can say so. And we know the probability of head plus probability of tail is equal to 1. Just in the first observation we have seen that. So can we replace this probability of tail with probability of not head? Yes, we can do so. So we got probability of head plus probability of not head is equal to 1. So we got our formula PE plus PE bar is equal to 1. This is very important formula and you can directly solve many questions based on this formula. Moving further, let's also understand about the playing card, which is very important and generally asked in the examination question. And you should know this because in the future it will also be used in the permutation, combination and other exams. In the playing card, we are having total 52 cards. 13 diamond, 13 club, 13 spade and 13 heart. We are having total 4 category. Here the diamond and heart are in the red color and club and the spade are in black color. So we can say we are having 26 card as red and 26 card as black. Here each category, that is we are having 4 category, each category is having total 13 card. That is 13 plus 13 plus 13 plus 13 is equal to 52. Let's see what are these 13 cards which are common in all the 4 category. The 13 cards include 1 ace card, 9 number card and 3 face card. Ace, that is this is the ace card, and number card we know from number 2 to number 10, and face card are 3, that is jack, queen and king. We are having total 3 face card in each category. In totality, these 13 cards will repeat in each category. So can we say we are having total 4 ace card and which are having basically 2 black ace card and 2 red ace card. We are having 4 jack, 4 queen and 4 king card. That is 2 black and 2 red. We are having total 12 face card. These are the 12 face card, out of which 6 are black face card and 6 are red face card. So these are the total 52 card. Just take some time and observe this 52 card. Suppose we have to calculate the probability of getting red king card. So what it will be if we use the formula of probability, in the denominator all the 52 cards will come. And what will come in the numerator? In the numerator the favorable condition will come. Let's see what are the favorable condition. The favorable condition are total 2 red cards only. Out of 52 cards we are having only 2 red cards. So these 2 red cards will come in the numerator. We got the probability as 2 by 52. That is 1 by 26. Got it? Similarly, if the question is find the probability of diamond ace card. So what will be the probability? The denominator will remain the same, that is 52, the total cards. And the favorable condition is only 1 diamond ace. We are having total 4 ace card and the diamond ace, which is the question, is only 1. So 1 by 52 is the answer. Similarly, if the question is find the probability of getting the face card out of the pack of 52 card, that will be 12 by 52 because we are having total 12 face card. So we got our answer as 12 by 52. Similarly, we can form different type of questions based on the different card, like the probability of getting king, queen, black, white combination, anything we can match. If you know all these 52 cards, you can solve any of the question. Got it? So let's move to the next concept. We will take some questions and we will go slightly fast and make you understand or refresh the concept. Okay? So this is the NCERT example question and very important question in which we will brush up your concept. In this question, we are having a bag with 3 balls and one ball is drawn at random and we have to calculate the probability of getting the ball of different color. Here, if we use the formula of probability, in the denominator we will get all the 3 balls. That is, all the possible outcome are all the 3 balls. And if we have to calculate the probability of yellow ball, in the numerator the favorable condition is only 1 yellow ball. So we got our answer as 1 by 3. Similarly, for the red ball, the favorable condition will be only 1 red ball in the numerator. That will be 1 by 3. Similarly, for the blue ball, 1 blue ball in the numerator. So the answer is 1 by 3. So we got the probability of yellow, red and blue ball are same, that is 1 by 3 each. If we add the probability of all the 3 events, that is 1 by 3 plus 1 by 3 plus 1 by 3, we will get 1. The observation that we have previously seen, that is, if we add the probability of all the elementary event, we got the addition as 1. And if I ask you what is the probability of not getting the yellow ball, that will be equal to the probability of getting the red or the blue ball. So we got red and the blue ball in the numerator. Why? Because that is the possibility of not getting the yellow ball. If it is not a yellow ball, then it will be either a red ball or a blue ball. The denominator will remain the same. We got the answer as 2 by 3. Got it? We can also use the second observation, that is PE plus PE bar is equal to 1. That is P yellow plus P not yellow is equal to 1. And we have already calculated the probability of yellow ball as 1 by 3. We again got our answer as 2 by 3. So you can use either of the approach to solve the question, but you should know all the approaches. Moving further, now suppose let's take a case. Now we are having 2 yellow ball. What will be the probability of yellow, red and blue? In the denominator, now we will have 4 ball. 2 yellow, 1 red and 1 blue, that is total 4 balls in the denominator. For the blue, the numerator will be having only 1 ball, that is only the 1 favorable condition. For red, it will be 1 red ball. For yellow, it will be 2 yellow balls. Now we are having 2 yellow balls, so the favorable condition will be 2 yellow ball. So we got our answers as blue 1 by 4, red 1 by 4 and yellow 2 by 4, which is 1 by 2. Got it? We are only refreshing your concept. If you want to go detail into this concept, check out our videos. The link is given in the description. Moving further, we have seen the tossing of the coin and rolling of the die. Let's see what will happen if we toss the 2 coins. Here we are having 2 coins. And let's see what are the different cases that we can get when we toss the 2 coins simultaneously. So we can get the different possibilities. The first is that we can get either head or we can get head and tail, that is head in the first and tail in the second, or we can get tail in the first and head in the second, or we can get tail in both the cases. So we can get total 4 scenarios. This is very important because generally questions are asked what will happen when we toss the 2 coins. So when we toss the 2 coins, we will get all these 4 outcomes. Okay. Suppose we have to calculate the probability of getting at least 1 head. So let's use the formula of probability. Here in the denominator, all these 4 cases will come. So we got 4 in the denominator. And what are the favorable conditions in which we are getting at least 1 head? If you observe, we are having total 3 cases in which we are having at least 1 head. The 4th case is having 2 tail, so the 4th case will not come in our favorable condition. Only first 3 will come. So we got 3 in the numerator. Our answer is 3 by 4. If the question is find the probability of getting at least 1 tail, the denominator will remain the same. And in the numerator, our last 3 cases are satisfying the condition. So we got 3 in the numerator. If the question is what is the probability of getting the same output? Same output means either we are getting head or we are getting tail. So we are having 2 scenarios in which output of both the coins are same. So we got 2 in the numerator and total 4 in the denominator. So we got 1 by 2 as the answer. Got it? The case of 2 coins. Let's see the case of 3 coins. We are having 3 coins. So coin number 1, coin number 2 and coin number 3. So what are the different scenarios or the cases that we can get when we toss the 3 coin? In the single coin case, we are getting 2 output, head and tail. In the 2 coins, we are getting total 4 cases. Last observation that we have seen. In the 3 coins, let's see how many cases we can get. How we will proceed with the same. In the first case, that is in the first coin, we can get total 2 output, head or tail. Similarly, in the second coin, we can get head or tail. And similarly, in the third coin, we can get head or tail. That is 2 output in each of the 3 coins. So we are having 3 slots. So the total output that we can get is 2 into 2 into 2, that is 8. So we can get total 8 scenarios when we toss the 3 coins. These are the 8 scenarios that we can get. Got it? How we have done? We have multiplied 2 into 2 into 2. Similarly, if we are having 4 coin, then we can get 2 into 2 into 2 into 2. That is 16 output. If the question is for the 3 coin case, what is the probability of getting the same output? That is head, head, head or tail, tail, tail. Out of this 8, we are having only 2 outcome which are having the same output. That is the first and the last. So we got 2 cases in the numerator and total 8 cases in the denominator. So our answer is 1 by 4. If I ask you what is the probability of getting at least 2 head? So if you observe at least 2 head, we are having only 4 scenarios. These are the 4 scenarios that will come in the numerator. So we got our output or the answer as 4 by 8. That is 1 by 2. Got it? In the similar manner, we can frame any number of questions. That is, what is the probability of getting at least 2 tail, 3 tail, different scenarios we can imagine. If you know all these 8 outputs, you can solve the question. Let's move into the next case of rolling of 2 dice. This is very important and generally also asked in the exams. So let's see. Suppose we are having 2 dice, one is blue and one is gray. If we roll both the dice, we will get total 36 outputs. These are the 36 output. Just pause the video and take some time and observe all these 36 output. These are very important. Okay, you have observed it. Further, let's replace this dice with a number. We are having total 36 output. The question is generally asked about the sum of both the dice or both the outputs. Let's do the addition. We will get the minimum sum as number 2 and the maximum sum as number 12. Why? Because the minimum number that we can get on die is 1 and 1. So the addition is 1 plus 1 equal to 2. On the maximum side, we can get number 6 on both the dice. So we got the output as 6 plus 6 equal to 12. So the range is from 2 to 12. And if the question is what is the probability of getting the sum as number 2, that is addition as 2. So what are the total number of cases in the denominator? That are total 36 cases. And what are the cases in the numerator that we can get the number 2 or the addition as 2? That is only one case. So we got the answer as 1 by 36. Similarly, how many cases of 3? If we have to calculate the probability of getting the sum as 3, that will be only 2 cases. So we got our answer as 2 by 36. Similarly, you can observe how many cases you are getting for number 4, 5, 6, 7, 8, 9, 10, 11, 12. Firstly, it is increasing, then it is decreasing. You should know this because in the exam, the question is generally asked about this 36 output. You can quickly draw all this output in the exam on the back of the page. It will be really helpful. If you can remember this, that is good. You can remember like this. Here it is 2, then 3, 4, 5, 6. Then it is like decreasing 7, 8, 9, 10, 11, 12. Okay. So we got the case of 2 dice. 3 dice will not be asked in the exam. That will be a tough one. The other type of question that you can get is the scenario based question. Like one question we have done regarding the crashing of the helicopter. One area is given, a rectangular region is given, and one lake is given in that rectangular region. The helicopter has crashed in this rectangular region, and we have to calculate the probability of crashing of the helicopter in the water region. So these type of scenario questions are also asked in the exam. How we will proceed with this? We will again use the formula of probability, and in the denominator the total case will come, and in the numerator only favorable case will come. Here the total case is the area of this rectangular region, and the favorable case is the water region, that is this rectangular water region. That will come in the numerator, and in the denominator the total area of the rectangular region will come. Similar type of question like this bulb question is also very important. We are having total 20 bulbs, and this is also a scenario based question. Like out of this 20 bulb, 4 are defective and 16 are working good, and we have to calculate the probability of getting one defective bulb. We are taking one bulb out of this 20 bulb, and we have to find the defective bulb case. So we are having 20 bulb, that will come in the denominator, and the defective 4 bulb will come in the numerator. So we got our answer as 1 by 5. The important thing is that in the second case, it is given the one bulb which is taken out is a good bulb and it is used. Now we are remaining with only 19 bulb. So now we have to calculate the probability of getting the good bulb. Now the denominator will change from 20 to 19 bulb because one bulb has been used and it is gone out. Now we are remain with 19 bulb. And now the question is changed. Now we have to calculate the probability of getting the good bulb, that is non-defective bulb, that is only 15. Initially it was 16, one is gone, we got only 15. So the answer is 15 by 19. Such type of scenario based question you should observe and think in your mind. Do not rush and apply the formula. Observe the case, what is given in the case, whether it is good bulb or the bad bulb, one is taken out, how the total sum will change. All these things you should understand, then only proceed with the answer. Do not rush and jump to the formula, that will be really dangerous. Got it? We have gone slightly fast because this is the summary. If you want to again go to the detail of each video, refer the detailed video in the description. That will be really helpful. So best of luck for your exam that you are preparing for, and go and crack the exam. So students, we have done the last lecture of the probability series. We have done all the videos. Very long series. Hope you have gained something out of it. Thank you very much. I am Gurmeet Singh signing off from this probability series. If you want other lectures on the class 10th mathematics series, check out our YouTube channel. We have plenty of videos on various series, all using the animation and the visual tool. Hope you are enjoying our new way of teaching. That's CREATA Classes. We believe in adding creativity to the learning. Thank you very much. Best of luck and have a great day. Bye for now.